Hello, hi everyone. Welcome to this session of DB Mastery series about cloud native databases. Today we're going to talk about running non-cloud native databases, as you well know, in the cloud native environments. Let's get started. First of all, my name is Alkin. I'm the Director of Services at Altinity. I am also known as an open source database evangelist, mostly known in the MySQL space. I do run the services organization at Altinity, focusing on ClickHouse and the ClickHouse ecosystem, running in the cloud, running on-prem, running on the cloud native environments. That's where this talk come from. Also, I am a DBA, SRE, and a technical manager in my past. I have some recognitions that I listed over here, but most importantly, um, giving back to community was my focus in the last decade and a half in the open source community. So for the agenda today, we're gonna talk about yesterday. We all need to know about our history about what happened, and today the cloud native paradox that is actually really taking our time and material and also all the efforts to run operations and databases. And tomorrow, where are we heading with the AI-based cloud native databases and where they are bringing? I have some thoughts on that, some experiences, experiments, let's put it that way. And because it's evolving so fast as of today. And maybe we can talk about some of the real world cases and practical takeaways from my experiences over the course of the open source database evolution that included some of the well-known and popular databases. So, two worlds. Databases definitely were born before the cloud. And the ones that we actually use, the LampStack one, MySQL, and the Postgres one, is around 30 years old, and they all predate the virtualization cloud, elasticity in the storage in the containers and today's complex clustered Kubernetes environments where we actually run databases. And traditional LTP systems like MySQL and Postgres were adopted in the cloud. That was painful, and we had a lot of resistance and restrictions also. At that time, before even the cloud, we had the virtualization, which made things very easy to deploy, but hard to manage when things went south. And in the meantime, there's also analytical engine like ClickHouse were born. It's something that I do on day-to-day basis also for the distributed environments. And the bridging the stateful systems in the cloud native orchestration was the biggest challenge over here. Basically, the cloud native operations, we'll talk about that a little bit, it was not designed for the stateful workloads. And hence we ran these systems on like single machines. This is the era after the mainframes, and then we had actually machines that handle the database workload as well as the application workload, and then we separated out those out. And but the scaling was kind of a myth at that time because to scale an operation that was slow, we would need to basically get bigger machines with faster disks, faster more memory, and better networking. And yes, we did run backups via cron jobs, and maybe we still do. But they were like we would treat them as pets. And they we actually used I actually personally used several of ancient Greek themed naming conventions for like giving a very ancient warrior name for a server that served the database, and then maybe something else for the application server. So the roots came from vertical scaling, and it was just like increasing the memory size. And then of course we had to deal with RAID controllers and their RAID, which may not be the case today's elasticity. And yes, we did use a lot of shell scripts and cron jobs to monitor the databases. And then we had instances that we actually had cases where the systems really crashed due to the disks or corrupt disks, and maybe that's not something we hear today a lot, but yes, disks were corrupted because of the load that it couldn't handle, and then we actually had maintenance windows to swap disks and put things around. So yeah, sharding was really something that didn't exist until the last maybe 2 decades. So why this talk matters in the 2025, 2026 era is 80% of the production database is still not cloud native. And that's the reality. We made them become a reality to be worked on cloud native environments like Kubernetes. And we also still run stateful services outside of these environments. And if you look at today's design, we have control planes that is somewhat in in the cloud, but not really cloud native environment. That because the orchestration will be too complex if we actually put everything in the same basket. And there's also cost pressure with the storage compute separation. This is maybe handled better, but still there's a long way to go. Well, the Gen AI and the vector workloads are still very popular, and they're pushing the limits for the databases that we're getting into. As you all know, that there's a lot of traction on the MCP servers that actually gateways the Gen AI tools, utilities, and applications to the databases, pointing to databases, and they will actually pushing extra workloads into these systems. And then there's also vendor ecosystem. They are like operators, frameworks, and orchestration, which we call it the database as a service, and then or the cloud orchestration, which encapsulates all of these into the ecosystem. So what we don't want, what we didn't want, the trends didn't want is the pets, because the pets only did what it could do, but the cattles actually had a lot to carry and serve, and that's the theme over here. Uh, Cattle friendly without losing durability, infrastructure as a code. So, but that came with some drawbacks and maybe pros and cons to it. And when you look at it, the persistence model, stateful databases in the stateless orchestration required additional stateful orchestration, like the key value stores that where we keep the metadata. And oftentimes is you will hear about etcd, zookeeper, and other tools to manage the orchestration. Again, those are also stateful workloads, and they also have their own replication, primary and replicas within, because they need to be highly available. And that's where the some of the um, limitations come from. Of course, there's a scalability, networking, and observability. This is another subject of a talk where once you have all this um, orchestration done, how do you actually catch the issues, latencies, errors, locks, because there are going to be a lot. The observability points are counted in hundreds of thousands or millions of records per second right now, flowing into the database, another data store maybe, and then being analyzed and maybe with some AI tools, maybe with some observability tools, identified that you can actually trace back what happened in that. So now the pattern became a very de facto standard in containerization. The containers actually the base images and then being pulled. Now there are new, Docker swarms. There's some other methodologies are evolving around this. I have some thought process on that, but let's go through the storage replication operators. They are all part of the ecosystem, and also then the containerization can have its own complexity, because then you have the operator and multiple data sources. And now this architecture changed a little bit with the storage optimization, because a lot of the data that we keep will need to be carried over to some sort of an object storage because of the costs. And the orchestration of object storage is also another non-cloud native operation. And that's basically it's an endpoint that we call it, or TTL out the data. And we still have to put that it's part of the optimization process within the ecosystem. So when we map all of that, before and after, HA failover, for example, we actually use operators, but operators are not sometimes are not very smart enough to do leader selection when it comes down to databases, because if it was just a stateless workload, you would just fail over from one to another without knowing the state of the previous. But we can't do that with the databases. So we use operators, give it more logic, more intelligence to how we actually do the failovers. The backups don't work externally, because the pods get restarted and they rotate it around, or it needs to know where we actually keep those endpoints, like the object stores. And it's scaling, of course, the stateful set with the PVC expansion. We can talk about that a little bit, because the PVC is an important factor for keeping the statefulness of that each node of the data point. And observability is basically is becoming more and more important as these clusters or implementations growing. They're no longer ability to use like a single host or a tool or a human readable format of a single event. There's going to be thousands of events. And of course the configuration, infrastructure as a code we mentioned definitely needs to have a declarative manifest that is run from a configuration, and the automation should need. So overall, the cloud native paradox became the Kubernetes, and the stateless pods and databases are really still stateful. So what we made it work with the help of operators, and they do work, but they require additional skills, not from the skills from the AI agent, but skills from the infra side. And we still need to have the right coordination, right settings, and the right implementation to be able to scale those systems. And the last point over here in the columnar systems, such as ClickHouse in this case, is also embracing stateless workload, which is also a stateful workload, but its distributed architecture helps a little bit, makes it a little bit more easier in terms of handling being in the cloud native. But it still needs to be, again, use an operator, still needs a PVCs, still need to, moving IPs and orchestration, definitely needs an observability in order to be managed. At the end of the day, it's still a database that requires consistency, even though if it's eventual consistent system. So the server engineering, the storage is 80% of the running databases in the Kubernetes, and networking is going to be the very important factor over here. Definitely highlight of the last few years, I would say, maybe since the pandemic, the object storage has become, because CPU used to be cheap, memory used to be cheap, and disks used to be very cheap, while CPU became more expensive because there were more faster and specialized CPUs that had ability to do bigger IOPS. Then the storage became more expensive eventually. Now we have to kind of a cost cutting objective for the getting storage utilization of the object storage and the S3 stuff. The operators, we definitely need to touch base in the operators, and there are dedicated operators for almost all databases right now to deploy in cloud. Uh, Personally, I highly recommend using an operator and implementing the right operator for the right use case. And the only caveat is the making sure once the operator is deployed, the recovery upgrade uh, procedures needs to be tested a lot, in the sense of you have your Kubernetes or the environment, managed Kubernetes environment will have its own dependencies and upgrades. The operator needs to be upgraded and developed in continuously, and in the meantime you have also the database upgrades patches that needs to be applied. So the combination of all these three in a stateful workload still requires additional orchestration in that sense. So in the going back to the MySQL, the operator manages the failover. uh, it will fail over. It can use in the most scenarios it can use the leader, or it's the clustered the systems already have the built-in leader selection, like the raft or some other methodologies, but we need to make sure that it is configured the way that it will manage the failover. Otherwise, if it failed over uh, to a node that was used as a replica, it will create more problems than it will save the points. Then you'll have end up with the uh, duplicated data or um, double-headed dragon. So that's not something we recommend. And but this can be automated failover, and it will help with the restarts and rolling restarts. This is a great implementation method for patches and upgrades. And and the the important point that we hear a lot is the class mismatch and the jobs failing and the cold nodes, and then storage needs to be definitely managed well in that sense. So going back to the operator architecture, it looks like this. We still have to do the persistent volume claim, PVCs, and the storage. Of course, then the storage needs to have some sort of object storage, and this will help in that. Um, there are some known operators out there, and um, some of them are very popular, like the Percona's MySQL operator is very battle tested one, and it has integration with the orchestration of some of the tools, utilities, and the backups. So the other ones are also may require you to explore some other tools, may not be part of the ecosystem, like the MySQL operator from Oracle is using MySQL shell and the router integration, whereas some others may not be using those. So that's a kind of a different orchestration than one of the other. And there's also clustering solution that can actually be used. These help the orchestration of the operator, and then if you run it behind an operator, they'll be able to do the orchestration within that. There's also proxy solution in the MySQL ecosystem to again, these are all for adapting to the cloud native ecosystem. There's sharding solutions like Vitess that will be truly adapted to the cloud native ecosystem, because then if you're actually scaling out, adding new shards into the ecosystem, you can basically automate that around the system that already works in the cloud native environment. Going back to Postgres, very popular open source database, and it also has its own operators, and basically the OLTP workloads within the PVC bound storage. It has a slightly different methodology in the how the workload is handled. Um, so that's the context of it. Also in the ecosystem provides bunch of other options to do the automation. and there might be some bottlenecks. There's definitely some room to improve over there, and make sure that you have a stable HA and predictable failover, and reduced manual operations from here. Also here, there are some options. I think the Patroni operator is very popular and more battle tested than the others. But again, these are a couple of options here. Like I mentioned earlier, these operators will have to use some sort of a leader election to be able to do so the Patroni uses Raft again, as mentioned earlier, etcd, another key value store, to keep the metadata synchronized and up to date. Persistent volume migration is not too different over here across the databases. For Postgres, it's somewhat similar, and but there are some interesting notes about read ahead log archiving, and that basically make sure that you actually are aware of some of the backup and the failover limitations that will occur if you actually import this, implement this. And what's for tomorrow? Tomorrow is going to be is it going to be a different framework? For example, all of these techniques or technologies mentioned over here are available in the cloud. Once again, it's whether it's a SaaS environment, they will still be using these operators and managed storage and services behind certain control planes. Can you do a DIY? Definitely you can, because most of those are already open source, including the operators tools, backup tools, or failover tools. But that will require definitely a trade-off between focusing on a business, or whether you actually have time and material or infra to be able to support these, because then it may become an overhead whether to focusing on the business instead of using one of the options out there. And there are also a packaged control planes that you can be actually adopting in your own cloud and implement those to be able to manage, but definitely also implement observability piece of it, so that you don't actually fall into a trap of not catching the things that are actually in the cloud native area. We also see a good adoption that was made for the ClickHouse deployments. So we are also seeing a lot of on-prem cloud native deployments for large scale operations, especially for logging or time series data that the business needs, that requires ingestion pipeline to write a lot but process later type of environment. ClickHouse stands out with its own built-in sharding, having the replica and a coordinator free scaling in terms of the operation. So this is where it excels. Um, it's basically decoupled storage, compute, and the metadata is actually helping out the operations versus the other OLTP databases such as MySQL and PostgreSQL. And yeah, it does actually sharding out of the box, and it will do the active merges, and it has shared nothing storage, which is pretty cloud native in the sense of implementations. And it can be implemented on-prem or in the cloud, or you could use automation around Helm charts, and you could use open source Altinity operator in deploying into the cloud. And what's for the future? Going for the AI native database operations. So AI is going to be even more trending operation for databases. Right now, Yes, there are MCP servers, but mostly we trust MCP servers or cloud environments. Apart from the development, we only use it for read-only operation, for exploration, analysis, and maybe reporting. And that needs to be very kept, strictly for that, as AI is like a kind of a uh, not a newborn, but now it's a child. So you need to tell what needs to be done and where are the limitations for it. It may do things that you may not want or it may not want. End up with saying, "Oops, sorry." Now, which is going to be a kind of a case. So we will be seeing more intelligent database operations from AI, and what that come from that we need to be ready for that type of workload also, and that's something will be maybe a separate cluster for that, separate replica for that, and then also come tomorrow it's going to be AI driven scaling based on embeddings and machine learning time series of data. So um, at the end, there's going to be a unified data frame for databases, which we actually have already. Some of the implementation that some of the open source tools already combining multiple operators, because you may have multiple solutions for different databases, say Postgres or MySQL for OLTP workloads, ClickHouse for analytics workloads, and then where you may have to combine with other pipelines such as from Kafka, and that's you will actually definitely. But I am going to highlight over here again one more time with the utilization of object stores, and the data lakes is going to be a kind of a important factor. And hopefully all become declarative, autonomous, and self-healing in one day, where the automation will help us to do better things with our database. And this is the key takeaways. Definitely build a replica model. You have ability to do, rolling restarts, failovers, and basically fix things in the production environment faster. And this will apply for all the database implementations that we recommend. But ClickHouse, because it's the compute and storage are separate, so it's basically easy to do that. And that's where I end up my talk over here. Hopefully, this will give us some ideas. I also have the books over here if anyone is interested in doing that. I also would like to offer a ClickHouse training, 50% off from the next available slot. Our very popular ClickHouse trainings are filling up fast. So if you're actually interested in getting trained on ClickHouse, please do to check in the trainings also. And thank you very much.